All right, folks. Let's let's get started. As we kind of wrap up the rest of the semester, more than welcome to show up 8 o'clock next Monday. I won't be here. I don't think most of your peers will be. But please remember, we do have the final exam on Monday night. So what we're going to do today is I just had two last slides I wanted to go through talking about toxoplasma. Then I'm going to take you through a couple of examples of questions from final exams in the past, just to give you kind of a feel for. I think there's really three common themes that I think I look for in that exam. And then we'll just open it up to questions, and we'll stay as long as people want, as long as we get out of here by 8:50 for the next class. So we were wrapping up talking about the one and only parasite that we'll mention this semester, toxoplasma, which as mentioned before has a very high mortality rate, very high hospitalization rate. Not a heck of a lot of cases per year when we compare it to things like Salmonella and Campylobacter. But we'd mentioned that this particular organism, its reservoir, or what we refer to as the definitive host, is the domestic house cat. So this is because this organism can not only exist within the entire body of the cat, but also exist within the intestinal environment. And this is kind of unique. So when the cat will shed the organism in the form of these this kind of a slightly dormant form called the oocyst. It'll get picked up by small animals, and when these animals ingest the oocysts, they'll end up becoming what are called tachizoites, that are kind of a motile form that now will become more invasive. And where they'll end up going is to the deeper tissues and the muscle, where they'll form cysts that are basically encased within these tissues, and they can be dormant for very long periods of time. So they can basically, these small animals can be carriers, but then it can go back and to recontaminate cats when, of course, the cats eat these small little critters. So this was kind of the difference between the definitive host, which is only the cat, and the intermediate host, which is pretty much everything else. I would mention that how we pick it up is through the consumption of undercooked meat, because just like with birds and cats, other animals can ingest the oocysts that are in the environment, can be carriers, and through the consumption of these foods is primarily how we pick it up. This schematic from the CDC's website is showing blood transfusions. There have been cases of transmission through that route. Obviously, that's not something we concern ourselves with as food microbiologists. But additionally, using contaminated groundwater, irrigating fresh fruits and vegetables, things that are not going to be cooked. There have been plenty of cases that have been documented through that route. And we'd also mentioned, of course, it can be, the oocyst can be in, feces in litter boxes. And this is a particularly concern to pregnant women, who can, pick it up, in which this is an organism that actually can cause, issues, within, adults and such, but also, targets the developing fetus. So that was, basically the lifestyle of toxoplasma, and how it transmits to us and to our food. So the three largest concerns about this particular parasite, again, that term YOPI, young, old, pregnant, immunocompromised, are the four categories, just like Listeria, that are particularly susceptible to toxoplasma. And I think you can tell by that lifestyle, a lot of the issues that this protist causes has to do with the fact, that it basically it'll infect, muscle tissue, other organs. So it can cause all sorts of problems with the brain, with the heart, with the skeletal, muscles. And, it can become chronic, so we can be long-term carriers of this organism as well. But in terms of, the developing fetus, there is a condition called congenital toxoplasmosis. Congenital basically being a word that means, existing from birth, in which when the mother has become infected, this organism can cross the placental barrier, infect, the developing fetus, and, this results in a pretty high clip of fetal death, or with serious developmental issues, brain issues, when the child is born. So again, an organism that is particularly dangerous, to this population. So obviously, we're not eating, an awful lot of, undercooked, meat nowadays. So I mean, it's not that, we know how to control, the organism. We know how it gets around, so we know how to control it. But where we're beginning to see a lot more concern coming up is now that there's, with this, with certain individuals, there's an increased popularity of consuming many wild game meats, particularly boar and others. And again, these are animals that are known to carry toxoplasma. Through increased consumption of some of these particular types of foods, we've begun to see toxoplasma transmitting by those routes as well. And this is not the craziest slide I'm sure you've seen all semester, but of course we had to end it with this, because to me as a microbiologist, toxoplasma is actually an absolutely fascinating organism, because we've talked an awful lot about pathogens that we consume. They come from a reservoir, they get in food, we consume them, they make us ill. But in the end, what these organisms are really trying to do is come up with mechanisms that help them survive, or that help them get transmitted from one host to another. Toxoplasma, I think, has come up with one of the coolest mechanisms behind how it does this. So, as I mentioned, toxoplasma, it needs, basically it wants to colonize, the domestic house cat. That's where it's going to, persist for long periods of time, and that allow it to transmit, around. But we've said that, it will, through coming into contact with, cat feces, small animals such as rodents, rats and mice can be intermediate hosts, that can be, carriers. We also mentioned that what toxoplasma does when it gets into these intermediate hosts is, basically it, moves through the body and will colonize, muscles, brain tissue, and such as that brain tissue that's particularly important. So toxoplasma has come up with a mechanism to basically tweak the brain of mice that, as a lot of studies have shown, it makes the mice less fearful of cats. So you think, cat urine and the smell of cats, is basically it's something that's going to, trigger, kind of like a flight response in mice. They know that this is a predator. They know it needs to steer clear of them. But when toxoplasma infects the brain, it actually short circuits that that mechanism, that mice have that cause them to be fearful of things such as cats. So basically, in the end, instead of running away from a cat, mouse is just going to kind of look at it and, I don't know, think it's a playmate or something like that. So what toxoplasma has come up with is a way to kind of encourage, allow it to continuously come back and infect, infect other cats that will now allow it to spread through a population, pretty readily. So it's a pretty interesting way that a protist has come up with to make sure that it constantly gets transmitted back to its definitive host, where ultimately it wants to be. So any questions about toxoplasma before we move on? Okay. So with that, what I did want to end with, again, kind of bringing this whole thing about pathogens to the end, and before we move on to more serious stuff, let's actually talk to you about how everything you need to know about food safety we actually learned from Seinfeld.
Jerry, tonight is for a real treat. I'm personally going to be the dinner for you and Audrey.
Jerry, you okay?
Huh?
Is anything... Look like you've seen a ghost.
Is it?
Oh, wait till you taste this. Coffee's perfect.
Well,
Jerry, have some. You're not gonna taste it? Jerry.
All right. What I always love about that is every time I upload this video to YouTube now, I always get a message back saying, you've uploaded copyrighted content. So that's always a fun message to get. So with that,